Hey guys, this is Mr. Beckstrom, and I want to take a look at that problem number 10 from when this is the one that we're looking at in class. So it says solve the given system of exponential or logarithmic equations. So they give us these two logarithmic equations, and I'm going to solve it slightly different than the way we did in class. We had set it up, and I think we could actually solve it that way, but we'd have to use some kind of like a U substitution, which we haven't really done that much in class. So I want to look at it a little bit different. We're still going to start it the same way. So we know we have, or we can change from the logarithmic form to the exponential form. Once again, let's take a look at that. So if we have it where it looks like this, log with some base of something here is equal to b, we can rewrite that as that base raised to that b is equal to that x. So these two forms here and here are equivalent to each other. So since we're in the left form, I'm going to put it into this right form. So this first equation can be written as 3 raised to the y is equal to x. And the second one can be written as 9 to the y is equal to 2x plus 3. It's plus 3. Now here's the really tricky part. Oops, that should be a y there. So let me make that a clearer y. Alright. So I have kind of a clear substitution if I can make this a 3 to the y over here. And that's what I'm going to do. But it's going to be kind of a tricky way that I'm going to do that. So what I'm going to do here is I'm going to take this equation here, and I'm going to write 9 as 3 squared. So that's 3 squared to the y is equal to 2x plus 3. And then, really, since an exponent to an exponent, that's really just multiplication. So this is really just 3 to the 2y is equal to 2x plus 3 plus 3. And since multiplication is commutative, which means I can 2 times y is the same as y times 2, I can then once again rewrite this as 3 to the y squared is equal to 2x plus 3. So why did I just go through all that work? Well, because I know that 3 to the y is equal to x, right? So now I can just replace this 3 to the y here with x. So x squared is equal to 2x plus 3. And now I have an equation that I can actually work with and solve. So now I can take this equation. So x squared, subtract 2x and 3 from both sides, minus 2x minus 3 is equal to 0. So now I can factor that. So x, I'm going to have what, a minus 3 and an x plus 1 is equal to 0 when I factor that. So I'm going to have x is equal to a negative 1 and a positive 3. Now I need to check both of those values in the original thing up here. So if I put negative 1 and 3 in here, if I put negative 1 in there, I get log base 9 of 1. That's fine. If I put a 3 in there, I'm going to get a log base 9 of 9, and that's fine. So negative 1 and 3 work fine in there, but up here, if I put a log base 3 of a negative 1 in there, it's not going to work. Why? Because the domain of log functions is from 0, not including 0, to infinity. So we can't put anything negative in a log function there. So this is out of there. So the So 3 is going to be my answer. 3 is going to be my only answer that works. And they actually want the solution as an ordered pair. So what is the log base 3 of 3? Well, 3 to what power gives me a 3? Well, that answer is 1. 3 to the first power gives me a 3. So my answer would be 3, 1. I could also put that in the calculator. So I can do a base change formula, right? Because the log of 3 divided by the log of the base. So the log of 3 divided by the log of the base, which in this case is 3 divided by the log of the base. That's the base change formula. You just get 1. All right, so 3, 1 should be my answer, and that's it. All right, so the tricky part here was really going from here to there in order to get that substitution in there. Hope this helps. If you have any questions, let me know, and have a great rest of your week. Thanks.